Is my screen visible? Hello?
Yes, ma'am. It is visible.
So in today's session, we are going to discuss the practice assessment for the week 1. Already the introduction class is over about the week 1. So try to solve, okay, actively participate in solving the questions. Okay. Which of the following statements best describes programming? So what is mean by programming? To learn some language, either English or Telugu or Hindi or something. So somewhat, if you want to learn a new language, first what you will do? First, what will you learn?
Learn about the rules and the syntax.
Alphabets.
Yeah.
Okay. So first you learn the alphabets of that language. So here in the computer language, when you are learning some computer language, these alphabets are called character set. What is the character set supported by? Because everything will be formed using English alphabets and digits and underscore, some special symbols like that. So which character set is supported by your language? First you need to learn that. When you are learning a computer language, first you need to learn which character set will be supported by the language. Say for example, so what is the general character set we use in C language is alphabets, A to Z, small a to Z or capital A to Z, and digits 0 to 9. And some special symbols like comma, semicolon, hyphen, dot, something, etc. Okay. So these are the character set. These are the different character set that we use while writing a program in any language in general. Okay. So once you learn the alphabets, so then what you'll do? Suppose you are learning some new language, you have learned all the alphabets of that supported by that language. Then after that, what you'll do?
Learn the words and sentences.
Words. So you will form the words using alphabets. Using alphabets, we form the words. Here, in the computer language, using character set, we form tokens. Okay, using character set, using the character set of that language, okay, we form tokens. Tokens. So generally, these tokens means it can be many things. Constants. Say constants means say 78 is a constant. Some ABC, ABCD, some string is a constant. Okay, something like that. Okay, or a single alphabet, single character, which is there. Generally in C language, if you put something, a single character in the character set, kept it in a single quote is called a character. Whereas something which is kept in a double quotes is called a string. Okay. So if you specify the numerical digits like this, it is called a numerical constant. Okay. Say even you can have in the numerical, generally we will have integer constants as well as floating point constants also. So floating point constants will have a decimal point, specific place of the decimal point, whereas whole numbers are called integers. So these are the different types of constants you can form. So your tokens will include constants, variables, okay, your variables, Keywords. What is mean by a variable? For the time being, you remember like this. Suppose you want to say add two numbers. You want to say add two numbers. So let those two numbers be A and B. So we call them, let the two numbers be A. First number, we let them call it as A, and the second number, let them call it as B. So these are called, so first number you are calling it as A. That means this is the name of the, A is the name of the first number. B is the name of the second number. These are, we call it as variables. Okay, so generally variables are nothing but the name given to a memory location. In computer language, variable is nothing but a name given to a memory location. Generally, suppose you want to add 2 and 3. So how will say 2 plus 3? So where is this 2 and 3 will be stored? Generally, anything you want to evaluate in the computer will be stored in a memory. Okay, so 2 is stored in one memory location and 3 is stored in another memory location. So you are going to add these two values. So the memory location where the 2 is stored, we are calling it as A, and where the memory location where the 3 is stored, we are calling it as a B. So variable is nothing but the name given to a memory location. Say for example, here A is one variable, B is another variable, something like that. Okay. So for the time being, you consider that variable is the name which we use temporarily to represent a memory where the data is stored. Okay. So the keywords means there will be some words in the language which has some special meaning. Something like, say, suppose in the C programming language, so int means we consider that as a whole number. Float means we consider that as a floating point number, or a number having a decimal point. Okay. Say for example, char is used to represent a character. Okay. So if is used to specify some condition. Okay. While is a loop. So like that, you'll have some 32 keywords. There are 32 keywords supported by C language. So every keyword, this is a predefined word which is having the special meaning in the language. That is called the keyword. Okay. So that is also considered as a token. Okay. Operators. So to perform some operations between the variables or the constants, we use some operators like plus, minus, multiplication, star. So like that, we will use so many operators in C language. So those operators can also be considered as tokens. Okay, and so like that, you can form different types of tokens using character set. Using character set, you can form different types. There are other tokens also. We'll encounter all those later. Okay. So all these are called different tokens. So we will form the tokens using the character set of that language. So now we learn the alphabets. Using the alphabets, we form the words. And after that, what you'll do? After that, what you'll do?
Sentences.
Yeah, you will form a sentence. So here we call a sentence or as a statement. The sentence is in the normal language, we call it as a sentence. So that in the computer language, we call it as a statement. So using tokens, we will form the statements. There are different types of statements supported by the simple statements, compound statement, control statement. Like that, you will have different types of statements. So say for example, anything, a constant or a variable or an expression. Expression means So a combination of variables or constants combined with the operator is called an expression. Say for example, a plus 3 is an expression. Okay, an expression followed by a semicolon is called a statement. An expression, you can form so many types of expressions here. Expressions will also comes under tokens. So you can form expressions using tokens, and expression followed by a semicolon is called a statement in the C language. Okay, so a statement will perform some operation. Say for example, if I say b equal to a plus 3, where a value is 5. Say for example, if I say a is equal to 5 and b is equal to a plus 3. Suppose I have written some two statements here. A is equal to 5 is one statement which will assign a value 5 to a variable a, and after that I am calculating a value of variable b using the value of a, which is already defined in the above statement. So 5 plus 3, so the b value will become 8 now. So like that you can write some set of statements. Using tokens, you can form statements. So suppose you have learned the alphabets, you have formed the words, you have formed the sentences. Then what else you can do after that? What you'll do after that? We will prepare a document or a paragraph or a document. Is it? You can form a document. So that we call here as a program. So program is nothing but set of statements. Using set of statements, you can write a program. So program is nothing but the set of instructions, or the statement is nothing but an instruction. You are telling the computer to calculate this. This is an instruction given to a computer. So a program is nothing but a set of instructions given to the computer to perform something, to solve some task. Okay, program is nothing but set of statements. Program is nothing but set of statements. So what these statements will do, generally why we write a program? To solve some problem. To solve some problem or to solve some tasks, we write a program. So a program will consist of set of instructions given to the computer, which will be executed by your computer one after another to solve your problem. Okay. So now I think you understand what is program.
Yes.
Okay. Yeah. Now try to answer the first question. Which of the following statement best describes programming? It refers to how the data is organized and stored in computer memory. Is it that? No. Okay. So it refers to the process of instructing the computer to perform a given task. So why we are writing a program? To perform the given task, we are writing statements or the instructions we are giving to the computer to perform this particular task. So this is the correct answer. It refers to the process of instructing the computer to perform the given task. It refers to the hardware that a computer can support. It is not a hardware. Program is nothing but a software. It is a software, a set of instructions or the statements that will write to solve some problem. Okay. So the correct answer is it refers to the process of instructing the computer to perform the given task. Okay. Any doubt? Okay. So which of the following is or not a valid logical operators in programming? So there are many types of operators that are supported by the language. So the main logical operators available in any language will be and, or not. These are the logical operators. And, or not. Okay, these are called logical operators. Generally, these logical operators are used to combine some statements. Say, suppose you want to say, to join this particular course, you should get say more than 60% of the marks in the, say suppose in the test, and you should have an intermediate qualification. Suppose if I say you should have an intermediate qualification and you should get more than 60% of marks in the entrance test. Suppose if I say both those are the conditions to join this course. Suppose if I say, so we'll write, we will combine those two statements with and. Okay, you should pass intermediate and you should get more than 60 in entrance test. So we combine the two different statements with and. Okay, suppose if I say the eligibility for this course, maybe you might have passed either an intermediate or you should get 60% of marks in the test. So or means any one of the condition must be true, whereas and means all the conditions which are combined with and must be true to get the admission. Whereas or, if you combine with or, any one of the condition is true to get the whole statement to be true. Okay, not is just an opposite of the what we are saying. So these are called logical operators, and, are, not. So among these and, not are logical operators, valid logical operators, whereas assignment and COs are not logical operators. So logical operators. So and not are logical. These are not logical. So you are asked to pick not valid logical operators. Okay. So if you study the week 1 material which was provided to you in the course, this contains see here, arithmetic logic unit function. So what it will do, it will perform the arithmetic operations and logical operations. Logical operation, they are given that and, or, not are the logical operations. Okay.
Ma'am?
Yeah.
This material is not given to us, ma'am.
Yeah, it is there in your course itself, ma. You can download it from here. You have this portal now?
Yes, ma'am. But
yeah,
no, in that link, there are only slides from the video lectures.
No. You will have supplementary content. Lecture PPTs, you can, if you go there, you will find out.
Yes, ma'am. It's not there. So what should be asked? Or can you share the link, ma'am?
Yeah. Right.
Support email of the IIT Madras.
Hello. Hello. I didn't get you. Your voice is very low, ma'am.
1 moment, ma'am. Ma'am, am I audible now?
Yeah.
Yes, ma'am. I'm just asking you to please share the support email ID through which we can reach out to the support team and we can ask for any additional content that you share during the meeting.
See this one, cs1101@study.iitm.ac.in. This is the course mail ID. If you have any problem, you can post it here, or you can post it in a discussion forum also. DSA access will be there for you. So you can post the queries in the DSA so that it will be resolved.
Sure, ma'am. Thank you, ma'am.
Okay. Or you can write it to this mail ID, cs1101 study.iitm.ac.in. So this is the course mail ID. Okay. If you have any problem with this particular course, you can mail to this.
Sure, ma'am. Thank you, ma'am.
So which of the following statements is generally true? Which of the following statements is generally true? So the memory unit is responsible for performing arithmetic operations in the computer. So which part is responsible for performing the arithmetic operations? ALU. So but here it is given the memory unit. So this is wrong. This is wrong. So the registers are responsible for performing arithmetic operations. Generally, for what purpose we use registers? We use registers for storing a temporary data. So, but not for performing arithmetic operations. So, whereas the ALU is responsible for performing arithmetic operations in the computer. So, this is the correct answer. The arithmetic logic unit will perform the arithmetic operations in the computer. So, the correct option is the ALU is responsible for performing arithmetic operations in the computer. So, the above two are wrong. So, all of the above will also be ruled out. The next one, which of the following statements is true for split memory architecture? What is mean by a split memory architecture? Can anyone tell me?
Ma'am, memory is actually splitted into short-term memory, that is the
What
one
is
in the
split
CPU.
Memory architecture?
Yes, ma'am. Main memory and the temporary memory, that is the register.
So actually, what is the difference between? Yeah. So generally, how your computer will perform the operation? Say, suppose you need to add 2 plus 3. Suppose you need to add 2 plus 3. So 2 is the first data and 3 is the second data. How this will be performed? So generally, our data will be there in a memory location. Say, for example, our memory locations, all our memory locations are having a address. Say at a 2000 memory location, I have a value 2. And suppose at a 3000 memory location address, at an address of 3000 memory location, you have 3. So now you need to add these two values. Okay. So it cannot, your computer cannot, your CPU cannot directly read from the memory. It cannot directly read from the it cannot directly perform the operations on the memory data directly. It cannot directly. It will be able to access this memory, but it cannot directly perform those operations directly on a memory. So what it will do is it will fetch these values into one of its internal registers. Every processor, every CPU, in the CPU, inside the CPU, you will have a processor. So processor is the one which is going to perform the operations. So when it is performing the operation, it cannot directly perform the operations on main memory data. So what it will do, every processor will have some internal registers with it. Some internal registers, something like a program counter, instruction register, or register 1, 2, 3, 4, like that. There are some registers with every processor. So first what it will do is, the first value that it needs to perform the operation, it will be loaded into one of the registers. So first what it will do, R1 comma, say 2000. So from a memory location 2000, you retrieve the value load that value into one of the internal R1 is the let R1 be the one of the internal register of your computer. So from this memory location, you read the data, and that you load it into this register 1. Okay. Then again, it will load the second operator into another register. So from memory location 3000, you load the value 3 into R2. So what this statement will do? So now R1 contains 2. R1 contains 2 after this statement. So after this statement, so from memory location, it is reading the data and loading into your registers, internal registers. R2 will be loaded with 3. Okay. So now R1 contains 2, R3 contains 3. Now it will perform the operation. Suppose add is the operation to add two numbers. And what you need to add? R1 comma R2. That means the contents of R1 and R2 gets added, and again the result it will store it in R1. These two register value of these two registers gets added, and the result again it will store it in R1. So this is the instruction which specifies that. So that means now you will have something. R1 will contain R1 plus R2. Okay. So after performing the operation, that result also it will be stored in one of the internal registers. Okay. And then that register value it will send back to the memory, store, load. So generally this is L is called a load, and this is called a store. S means a store. So these instructions will vary based on your processor. Like if it is a 8086 processor, yeah, the instructions might be different. It is 80286, instruction might be different. Something like that. Okay, based on the processor, you'll have the instructions. Okay, so store is the instruction. So which will store the value of R1 into, suppose you need to add these two values, and the result, suppose you want to store it in a memory location, say 5000, say suppose in the 5000 memory location, you want to store the result of the addition of these two. So then what will where we have the result? R1. In the R1, I have the result that I am going to store it in a memory location 5000. So you can write store R1 comma 5000, so that it will store the value of this register, whatever value you have in R1, that will be stored in memory at a address of 5000 location. So this is nothing but what it will do. What is the value stored in R1? 5. So now that 5 will be stored at this memory location. So 5000 memory location now will contain a value 5. So in this way, so what it will, it cannot directly perform operations on your main memory content. So what it will do, first it will load those values into one of the internal registers and then perform the operation on the registers, and that registered data result again it will store back into your memory. Okay, so this is called a split memory architecture. That concept is called a split memory architecture. So so which statements are true about split memory architecture? The input data is fetched from the main memory and is temporarily stored in registers to perform the computations. So first changes what we did here. First we stored these data which is there in the main memory, that we stored it into one of the internal registers. So that is specified by this statement. The input data is fetched from the main memory and is temporarily stored in registers to perform the computations. And then finally what we did, after adding these two values, the result whatever you have in R1, that we are going to send back to the memory. So the result of the computation is temporarily stored in registers until it is written to the main memory. Okay. So in the split memory architecture, these two statements are true. Okay. So ALU fetches or writes the data directly from or to the main memory. So it cannot directly read or write, fetch or write the data from main memory. It will be fetched to one of the internal registers and then store the result in the internal register till you write it to the main memory. Okay. So these statements are true about split memory architecture. Any doubt? Okay. So which of the following statements are correct? What is meant by load? We have seen here. What is meant by load? What it is doing? Load instruction, what it is doing?
Main memory to the register.
It is moving the data from memory to the
From register.
So load refers to the process of moving the data from main memory to the registers. Whereas what is the store? The opposite. It is moving the data from a register to the main memory. So store refers to the process of moving the data from registers to the main memory. So these two statements are correct, whereas these two statements given in opposite. Okay. So the correct statements is load means you are moving the data from main memory to the register, and store means you are moving the data from register to main memory. Okay. Next one. A typical CPU keeps track of the position of the next instruction using a dash, fill the blank using appropriate. See, we said every processor will have so many registers. There are so many registers. Inside your processor, you will have so many registers. There are some registers which will have some special meaning, a special purpose. So one of that register is called PC. We call program counter. One of the register we will have in your processor is called program counter. So what it will do is, we said a program is nothing but set of instructions. Set of instructions. Your computer will take those instructions one by one and execute. One by one and execute. Say, for example, if I write something like this, A is equal to 2 is one statement, B is equal to 3 is another statement, C is equal to A plus B. I have written statements like this. Suppose this is the program I want to write to add two numbers. So these are the two numbers. So let the first number call it as A, second number call it as B. So I am adding those two numbers and then storing the result into another variable C. So these are the instructions I have written. So what your computer will do? First it will read this instruction, execute it. After that it will read this instruction and execute it. After that it will read this instruction and so it will execute each and every instruction step by step, one after another. Okay. So there are some, like suppose if you have something, so your data 2 is there in this memory location. So your control will transfer to that memory location and then read that data stored into this register, read this data stored into this register. So it will move, your control will move from one location to the another location in your memory. So then how it will know which instruction it is going to execute next? So first it will read this instruction. While performing this executing this instruction, it will move from one location to the another location. Again, after completion of that instruction, it should come to the next instruction. So these instructions are also stored in the memory. So to which location it need to come, how it will know is, your program counter will always say, for example, if this program is stored from say 7,000 location, so this instruction is stored in 7,000 locations. Say suppose this instruction is stored in 7,005 locations. Say for example, this instruction is stored in 7,010 location, like that. So once you are executing this instruction, your program counter will be loaded with the address of the next instruction to be executed. So your program counter will be loaded with 7,005. So that means while execute, after completion of this instruction, where you need to go and execute, it will be fetch that value from a register called program counter. So your program counter will always store the address of the next instruction to be executed. Okay. And that instruction will be stored in IR. IR is the instruction register. PC is the program counter, which will store the address of the next instruction to be executed, whereas IR is the instruction register, which will store the instruction that is to be executed. Okay. So a typical CPU keeps track of the position of the next instruction using program counter, where will be the address of the next instruction to be executed, where it will be stored. It will be stored in program counter. So program counter is also one of the internal registers of your CPU processor. So which of the following are true for the C programming language? C programming language. Okay. It is an imperative language. Imperative programming language means to solve a particular task, we write a set of instructions, a step-by-step process to solve the task. That is called imperative programming language. That means it not only solve the problem, it will specify in which order you need to solve, after which step you need to follow which step. So a step-by-step process to solve the problem. If it is specified like that, that is called imperative programming language. Whereas some programming languages called declarative programming languages, they will specify how they will give the solution to the problem, but they won't specify how you need to solve that, got that solution. How you got that solution will not be specified clearly. So that type of language is called a declarative programming language. Whereas an imperative programming language means, so along with the solution, you will know a step-by-step process to solve your task. So C programming language is an imperative programming language. It is an imperative programming language. And also it is a statistically typed language. What is mean by statistically typed language means, you need to know the data type of your variables in advance. Before writing the statement, first you need to specify what type of data you are going to store in that. Say for example, if I say a equal to 2. So before writing this statement, I need to specify a is an integer. A is a variable which contains an integer value. So you need to specify what type of data you are going to store in your variables in advance. First, you need to declare them. Okay. So that means before executing your instruction or before using your variable, you need to specify the data type of that variable. So you cannot, so suppose if I say, if I declare a as an integer, okay, right. If I declare a as an integer, let So that means later you can store only integer value in that. I cannot store something like, say, suppose if I write a statement something like this, that means what I'm doing in a variable A, I'm going to store a character, okay, or character or string, say suppose, okay, I'm going to store a string. So it will not be allowed, because we already specified that A is an integer. So that means it will accept only whole numbers inside A while calculating the remaining statements. This is a wrong one. This will not be allowed. That means, so this is called a statistically typed language. That means before using that value of that variable, first it is to be declared what type of values it will accept. Okay. That is called statistically typed language. If it is a dynamically typed language, so there won't be any data type. It will not be specified with any data type. Suppose Python is a dynamically typed language. Suppose if you say A equal to T, automatically A is considered as an integer. Whereas if I say this, later I can use the same A where I can store a string value also. Okay, so here when it comes from this statement to this statement, A will automatically converted into a string. So dynamically it will able to change its data type. Whereas in C language, you cannot able to change like that. So initially what type of data it carries, if you specify, you declare, the same type of data you need to store in the whole program. Okay. So that's why it is called a statistically typed language. Before using the variable, you need to specify what type of data it will contain initially itself. So once we declare initially the data type of that variable, you cannot able to change its value, change it that to other type. That is called statistically typed language. Whereas strongly typed language means strong, you can able to change the data type of that language also. Okay. And it is a structured programming language. C is a structured programming language. Because why we call it as a structured programming language means, suppose you want to perform a complex task. Suppose you want to perform a complex task. So within one step you cannot able to solve. So what we will do is, we will divide this complex task into simple tasks. Okay, simple task 1, simple task 2. Like that, you will divide the task into different simple tasks, and we will solve these simple tasks and then combine the result of all these simple tasks to get the result for your complex task. Have you got it? So when you want to solve a complex problem, okay, what you'll do, you can able to divide this complex problem into simple problems, simple problems. Okay, then we will solve each simple problem. We'll give the solution to each simple problem, and at the end we combine those solutions of all those simple problems to get the solution to your complex problem. So modularity, it will follow the modularity. It has a functions to so many, it will support so many functions. So to solve this simple task, we will write one function. To solve this particular simple task, we write another function. To solve this task, we write another function. So the output written from all those functions, we use it to solve the complex task. So that's why it is called a structured programming language. So these are the 3 features. Okay. So it doesn't demand high capacity hardware. So it is an imperative program. C language is an imperative programming language. It is statistically typed language, and it is a structured programming language. Next, suppose a CPU supports only addition and subtraction as arithmetic operations. Okay, so your CPU can able to perform only addition and subtraction. Only these two operations can be performed by your ALU, arithmetic logic unit. Okay, so consider the following steps to compute the value of A star. Now you want to multiply two different variables, A and B. You want to multiply. Let A and B located in memory location M0 and M1. A value is stored in M0 location. B value is stored at M1 location. And R0, R1, R2, and R3 be four available registers. So you have 4 registers to perform this operation, A star B. There are 4 registers available in your CPU. The result has to be stored at a memory location M2. Okay, so what they have given? So you have how many registers you have? R1, R2. I'm calling it as, sorry, I'm mentioning like this, R0. So this is R0. You can write it in any way, either this way or I'm writing like this. So R0, R1, R2, R0, R1, R2, R3. These are the 4 registers available to you. Okay, and in which memory location you have your A value? A value is there in memory location M0, M1. M1 is the B value. Okay, so what we are doing here is, so in the R0 register, initially we are storing, what we are doing in the R0 register, you are going to store
0.
So 0 is stored in R0, and A value, M0 means A value. A value is stored in R1. So in R1, what we have? A value. A value is stored in R2, R1, and in M1 is stored in R2. So that means R2 contains B value. M1 means nothing but B value. See here, in M0 you have A, and in M1 you have B. Okay, so B value, R1 contains A value, R2 contains B value. Again, R3 is also stored as 0. So later what they are doing? R3 is added with the R2. So R3 is modified now. So now it contains R3 plus, and means 0 plus R2, that is B. Now R3 contains 0 plus 3. Okay. Now what they are doing? R0 value is incremented by 1. So now R0, what it contains now? Incremented by 1. R0 contains previously 0. 0 plus 1 will be 1. So R0 now contains 1. Okay. So after that they given a blank, and then at the end our result is to be stored in M2. So what they are expecting, our result should be in R3. Final result of multiplying A and B must be there in R3. So that is the logic used there. So how we need to perform this multiplication is using a repeated addition. Generally, how we perform suppose I want to I want to multiply 3 and 4. Suppose I want to multiply 3 and 4. Suppose if I add the 4 3 times, if I add the 4 3 times, I will get this result. Okay, because my CPU can able to perform only addition and subtraction. It cannot perform multiplication directly. So the logic which I am using here is that repeated addition I am using. So how many times I need to repeatedly add this value? So what I am doing, I am taking a one counter, let it be R0. Initially I stored 0. Whenever I am adding the B value for the first time, it will be incremented by 1. Whenever I am adding the second time, it will be incremented by 2. Whenever I am adding the third time, it will be incremented by 3. So like that, till it becomes A value, A times. So R0 becomes R1. R0 becomes R1. Till that, we will add this. So this means these two statements are to be repeated. These two statements are to be repeated how many times? Till R0 becomes R1. Okay. So how can we fill that blank? See here. If R0 less than R1, go to step 3. So, but step 3, we don't want to repeat the step 3 and 4. What we want to repeat? We want to repeat step 5 and 6 only. So, this is wrong. If R0 less than R1, go to step, not step 3. Where we need to go? We need to go to step 5. So, this is wrong. So, second one is correct. If R0 less than R1, go to step 5. Okay, if R0 less than R2, so we are not comparing. So counter is R0 and the counter value must be reached to A. So A is there in R1. So you cannot compare with the B value. So the correct answer is if R0 less than R1, go to step 5. That means you repeat it. Like now what happened? Here R0 is less than R1. Here what we have A value. So R0 is, say in this case, suppose if I say A value, A is 3. For example, here consider this value is 3. Okay. Now B value is 4. Okay. So R3 is 0. Now what is the B value? 4. Okay. Now R0 is incremented by 1. Now again R0 less than. Now you check R0. What is R0? R0 less than R1. So what is R0? 1 less than, what is R1 value? 3. 1 less than 3. It is true. 1 less than 3. It is true. So now what you need to, another time you need to add. So you go to this step. Now R3 will be, what is R3 now? R3 equal to R3 plus R2. That means R3 already contains 4. Now you are going to add another 4 to that. Another 4. Another time you are going to add. And again you increase your R0 value. Now R0 will become now 2. Increment the R0 value. So now R0 becomes 2. Again here 2 less than 3. So again you go and add. So again this statement gets executed. Again this statement gets executed. So what happens here? R3 equal to R3. Already R3 contains 4 plus 4. Now to this you add another 4. Okay. Now increase your R0. So now R0 value is previously 2. Now R0 will be incremented by 1. so that it will contain already 2. 2 plus 1 is 3. It will be 3. Okay. Now, is it 3 less than 3? Because in R1 you have a 3.
No.
So this
Three
will
to
become
stop.
3 less than 3. So which is false. So when it is false, it will stop. So by that time you have 4 is added 3 times. So the logic which we have used here is A times we are adding B. So A times, so to specify that what we are doing, we are taking initially one counter which is initialized to 0, incrementing that counter till we reach A. Once we reach A, we are stopping. So if you didn't reach A, what you are doing? You are adding the B value to the register R3. You are adding B value to the register. So adding the B value to the register, increasing the R counter, these two statements are to be repeated as long as R0 is less than R1. So this is the correct option. You need to fill it in the 7th statement. Got it? Have you understood
Yes.
the logic? Next, suppose two devices, monitor and keyboard, are mapped to the memory location 51 and 67. Okay, that means in the memory location 51 you have a monitor and 67 is the keyboard. Okay, memory location 51 is the monitor, memory location 67 is the keyboard. Okay, we have to write a program which takes an input value from the keyboard and display it to the monitor. Identify the correct steps. So first we'll solve this. Okay, so 51, what is 51? Monitor. Monitor is an output device. Monitor means it is an output device. Keyboard is 67 is your keyboard. '67 is the keyboard. So keyboard is an input device. So you need to read from the input device. So generally how we'll write a program is, see, every program will have these steps. Input. Every program will have input, process, output. Every program will have these 3 steps. First, we need to read the input, and using that input, we need to process the data, calculate the output. Processing means you need to calculate the output based on this input, and then you need to display your output on the output device, that is on the monitor. So what you are doing here, suppose for example, we need to calculate area of a rectangle. Suppose we need to calculate area of a rectangle. Suppose you need to calculate area of a rectangle. So what to, you know the formula, area equal to length into breadth. To calculate the area, we have the formula area equal to length into breadth. Let L is the length, B is the breadth, A is the area. Okay, so if you know the length and breadth, then only you can able to calculate area. So when a problem is given to you, first you need to identify what is the input you need to solve that problem. So here, if you know the L value and the B value, then only you can able to calculate area. So L and B are your inputs. Okay, and what you are going to calculate, find out, that is called the output. Say for example, you consider, suppose you want to make a coffee. Okay, you want to make a coffee. So coffee is your output. What you are doing, that is nothing but finally what you are getting, that is the output. We call it as output. So coffee is your output. So to make the coffee, what are the ingredients that are required by you? That is nothing but an input. So what are the inputs for making the coffee? Hello? So you may require water, milk, sugar, some heater. So like that. Okay. So all those are the inputs that are required to make your coffee output. Output coffee is the output, and milk, sugar, heat, all those are the inputs. Okay. So how you are preparing coffee? The steps. First, you need to boil the water and then add coffee powder and then add milk and then filter it. So those are the steps, one after another, that you need to follow to make your output coffee. Okay. So that is called a process. So first you need to read your input. You take all your ingredients and then using these ingredients, you perform step by step to get your coffee. Coffee is your output, ingredients are your input, and what the steps that you are following to make that output. So first we boil the water, that is the first step. Second step, we add coffee powder. Okay. After that, we filter the decoction. After that, we'll add sugar and then we'll add milk. So finally, you will get, after all those steps, you'll get a coffee. Okay. So the steps that we are following to get your output from the given input is called a process. Okay. So finally, you will get your output. So in the computer terminology, what we'll say, whatever the input that is required, we read it from the keyboard. What input we want, that we read it from our input device, that is called keyboard. Once we will process that input to get the output, and once we got the output, we need to display that output on your output device, that is monitor. Then only you can able to see that output. What result you got, you can able to see only when it is displayed on your output device. So you need to read your input from the keyboard and process it to get the output. Once we got the output, you need to display that on the monitor, output device. Okay. So for this particular problem, what is the input now? What is the input? For finding the area of rectangle, what is the input?
The length and the breadth.
Length and the breadth. So you need to read the L value and B value from the keyboard. Okay. After that, processing step is this formula. You need to process the input to calculate the output. You write this statement. That is the processing step. So where is the output now? Where is the output now?
The area A.
A. In A, you have the output. Now you display the A value on the monitor. Okay. So that is how we need to solve the problem. So now you look into the, once you know the concept, now you look into your problem. So what is the problem given to you? Okay. So keyboard is at the memory location, monitor is at 51, keyboard is at 61. We have to write a program which takes an input value from the keyboard, display it on the monitor. So in what it need to do, first it need to read the input. So from where it need to read the input, read the value from memory location. Read from memory. Where is the keyboard? From where we need to read the input? We need to read the input from the keyboard. Keyboard memory location is 67. So read from memory 67. Okay. Read from the memory 67. Okay, and that where it will store? It will store it into one of the internal registers of your CPU. So it will read from memory location 67 and store it in one of the internal registers of your CPU. Then what it will do? It will store back. And storing, we call it as writing. Write the value in
from register to the memory.
Value from R. R is the register. From R to monitor. Output where we need to write?
Monitor.
To the monitor. So monitor is at the memory location 51. So 51 memory location. So this is the what we need to do. Read from the memory 67, store it into one of the internal register, and then write the value of that register to memory location 50. So read the value of memory location 67 into the CPU register R. Write the value of the register R to the memory location 51. So these two statements are all given in a jumbling manner. Wherever there is read, they might be given write, and wherever write, there is given read. And in the reverse also, reading from monitor and writing to keyboard. So that jumbling is given here. So the correct one is you need to read from your input device. Input device, that is keyboard. So keyboard is at 67. So you read from memory 67 and store it in the register. Later, the register value you need to write. Store means write. Read means load. So write the value of R to the memory location 51. Have you got it?
Yes.
Yeah. Next. Set of stored instructions used to direct your computer's central processing unit is called a program. Okay. Set of stored instructions.
Yes, ma'am.
So is called a program, and directing your CPU to do that, execute that. Okay. So set of instructions is nothing but a program. Which of the following components is responsible for managing the flow of data between CPU and other components? Generally, in your computer architecture, there will be so many components like input devices, output devices, and your CPU processor. So inside the processor, again, you will have arithmetic logic unit, memory unit, control unit, like that. Okay. So from memory, we will fetch the data and then give it to the arithmetic logic unit to perform the operation. So once we perform the operation, we will get the result. Again, the result we will send back to the memory. So which device will do, which component will do that is the control unit. So your CPU will do all those things. So it will transfer the data from ALU to the memory. In the CPU, inside the CPU, the control unit will generate those instructions from where to where you need to transfer the data. Okay. So which component is responsible for managing the flow of data from memory to the register or register to the memory? So that flow, who will manage? The control unit will give you the signals to transfer the data from whether from memory to the register or register to the memory. Okay, that will be specified by the control unit. What the ALU will do, it will perform the operations. Cache memory and RAM both will store. Cache memory will store the recent instructions so that your instruction get executed fast. Whereas the RAM is the main memory where your data is stored in main memory while executing your program. Okay. So the control unit is the one which will give the which will control the flow of data between CPU and memory, like other components, ALU, memory, between all the other components. it will manage the flow of data. Next, which of the following components is responsible for temporarily storing instructions and data during program execution? See, during program execution, actually, inside your computer, you might have seen your hard disk. Okay. In a hard disk is the secondary memory storage device where your data is stored permanently. Once we write store today, even you can come tomorrow and see that data. Okay, so it will store your data permanently. Once you write, it will be there till you delete it. Okay, whereas so it is a secondary storage device. Whereas your processor can able to read that data only when it is in the main memory. So that we call it as a RAM, random access memory, RAM, random access memory. So if it is there in the random main memory, then only it can able to read those instructions. So what we'll do, while executing your program, generally we store our program in your hard disk. Okay, so while executing this program, your CPU will load this program into RAM, so that it will be mapped to some memory locations. So it will read one by one memory location and then execute it. So only it will be able to execute your program when it is there in the main memory. Okay, so the main memory we call it as RAM, random access memory. So that is only stored temporarily. Once the execution of that program is over, it will automatically get deleted. Okay, so RAM is a temporary memory. Only it will carry those data during the execution of the program. Once the execution of the program is over, it will be run out of that memory. Okay, so the component is which component is responsible for temporarily storing the instructions and data during program execution? Means main memory, that is RAM. Okay, whereas hard disk and floppy disk are the ROM, not ROM, they are the secondary storage devices. They will store the data permanently, whereas RAM is a main memory which will store the data temporarily during the program execution. Okay, so next, which of the following are examples of input devices in computer system architecture? Okay, so what are the input devices? Keyboard, webcam, mouse. Printer is an output device, speaker is an output device, whereas mic is an input. So using mic, you can speak. Okay, so it is an input device. Using mouse, you can choose something. You are selecting something. So mouse is an input device and webcam is an input device. Keyboard is an input device. Whereas printer, you can see your output on the paper. So it is an output device. Speaker. So from you can able to listen to the listen. That means you are getting an output, a voice from the speaker. So it is an output device. So these four are the input devices. Rank the following in the order of how much main memory RAM they had. So actually these are the devices, IBM mainframe system, Apollo 11 guidance computer, Apple iPhone 3s, Arduino Uno. So all these are the famous device kits you have. So you can search through Google so that what is the memory RAM capacity of all these devices. so that you can answer. So the devices has this. So Arduino Uno takes more memory, much memory. It has Arduino. Arduino memory has a lowest memory. So 4 less than 2 less than 1 less than 3. It has the lowest memory, and then Apollo 11, and then IBM mainframe, and then Apple iPhone. So Apple iPhone will have the more main memory. Okay, so that is the order. You can Google it. Each device has how much main memory. You can Google it. Based on that, you can answer the question, like which is taken from lowest to highest. Which of the following are computationally equivalent in theory? Note, two processes are considered computationally equivalent if anything that can be performed using one can also be done by the other, and vice versa. Okay. Like Arduino Uno, MacBook, high-end graphics. Okay, so this these are the different processors, drivers. You can all these are, I think, processors only. So you can, using these processors, you can perform any task. So that can be either Apple, or it can be NVIDIA, or it can be any other processor. So all the processor will able to execute your instructions. So whatever the Atmega 328P device is doing, the same thing you can also do it using Apple M1. The same thing will also be able to do it in NVIDIA using the NVIDIA H11 GPU. So that means if anything that can be performed by the one can also be done by the other, then those are called computationally equivalent. So all these are computationally equivalent because whatever the instruction that you are running using this particular device can also be run using this device. It can also be run using this device also. So all these three processors are computationally equivalent. Okay. So these are the practice assignment questions. If you have any doubts, you can ask me. Hello? Hello, ma? Is it clear? Do you have any other doubts?
Yes, ma'am. Yeah.
So if you don't have any doubts, we can stop. If you have any doubts, you can ask me. Hello?
Ma'am,
Yeah. Vijesh?
actually, we should learn what is
Your voice is not clear, ma. You speak with.
we should learn what is the pre-recorded videos, right?
I didn't get you. Anyone can repeat what he has told me? Your voice is not clear.
Ma'am, should we learn only through the pre-recorded videos?
Should we?
Should we learn only through the pre-recorded videos?
Clear video.
Yeah, only through the pre-recorded videos.
Yeah, it will be recorded, ma. It will be recorded, available in your YouTube channel of this particular course. CS 1101. Every course will have a YouTube channel. So in that YouTube channel, it will be streamed. What we done the recording, we are streaming here. So that recording will be available in the YouTube channel of this particular course. You can
Ma'am,
search out. Yes.
yeah, today I joined late. So which week content we covered in this lecture?
First week. In the first week,
Okay.
practice assessment we have covered.
Okay, ma'am. Thank you.
Okay.
Ma'am,
So,
what should
yeah.
you search to get the recorded video?
Yeah, you go to the YouTube channel of CS1101 course. There you will have this streamed video.
Okay.
Whatever that I have discussed now.
Yes.
So that video you can find out in the YouTube channel of this particular course.
Okay. Thank you.
Class notes. Actually, it should be there in the course itself. Now let me search it out, because I have downloaded from there only.
Ma'am, please pin the YouTube video link in the calendar.
In the calendar.
Yeah, in a meeting below the meeting link.
Below
Like
the meeting link.
for the lectures. Yeah.
What you have? What do you want to say? Below the meeting
Ma'am,
link.
some lectures video YouTube video links is pinned in a Google Calendar. When we click on that day,
Okay.
we can see the link also for YouTube. Yeah.
This is for Google Meet, that to attend the class unit.
Okay.
This is the link to join the class. Join with the Google Meet. Okay. This calendar, whatever your link that you have, this when you click on this, you can able to join the class.
Okay, ma'am.
Let me search for this content where. Yeah, I think you can get it from here. Study material. To know more about the course syllabus, instructions, prescribed books, please click on the below tab. I think there we'll find out the material. Okay.
Okay, ma'am. Thank you.
Any other doubts? So you need to practice up to unit week 4. Okay, for your exam, you need to practice up to week 4. Actually, first 2 weeks is a theory session only. The first 2 weeks are theory session only, like this. Whereas the 3rd and 4th weeks, you will have C programming basics also. Any other doubts? Can I stop the streaming now? For quiz 1 up to 4 weeks content. Yes.